Hello? Is it clear? Hello? Hello? Hello?
हेलो।
हाँ, can you hear me?
सर आपका आवाज नहीं आ रहा है, कट कट के आ रहे हैं।
Please stay on the line. Hello? Hello? Hello?
हेलो।
Is it clear?
हाँ, यस सर।
Okay, okay, thank you. Hello? Now let us continue. Good afternoon to everybody. Hello?
सर आपका आवाज अच्छे से नहीं आ रहा है।
Hello? Good afternoon to everybody here. Now, once again, good afternoon to everybody. Can you hear me? Okay. Now, already we have discussed in the last class Riemann integrals concept
सर
and
आपका कुछ
hello,
सुनाई नहीं दे रहा सर।
hello, is it
सर
okay?
नो सर, आपका आवाज ज्यादा अच्छा नहीं आ रहा है, मतलब समझ में नहीं आ रहा क्या आप बोल रहे हो सर। आपका
Hello,
साउंड आ रहा है बट क्या बोल रहे हो ये समझ में नहीं आ रहा।
is this okay? Voice is it clear? Hello, hello, is this okay? Okay, hello? 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 Is it clear? Hello?
हेलो
Is this okay?
हेलो
Hello? Is it okay?
यस सर ओके बट अच्छे से नहीं आ रहा सर आपका साउंड आ रहा है
Okay.
क्या बोल
Yeah.
रही है अच्छे से नहीं आ रहा
Okay, no problem. Yeah, actually, this is the main problem in university. So this is not my problem. Anyhow, let us have continue. Today, we will discuss one more concept, very important concept in Riemann integration. This is the block number 3. Now later, in the last section, we will discuss much more concepts, definition of Riemann sums and Riemann integrals, and necessary and sufficient condition of integrability, and a fundamental theorem of integral calculus, and some other problems are also to have to practice on Riemann sums and Riemann integrals. Today, we will discuss one more concept, that is the properties of Riemann integrals. And before that, just you have to screen in the on screen place there. Screen share is there. Some more notes are also I have sent through WhatsApp is there. Just recently today I posted in WhatsApp. Now that is also one of these today's class are also through WhatsApp is there. Okay, and today we will discuss what is the continuous function, what is the function of a limit, and according to the definitions and properties of continuous function and derivable function, and we will discuss much more concepts on properties of Riemann integrals. Just you have to see on screen. Students, listen carefully. Please see on screen, please. Please see the screen. Okay. Now, today we will discuss the one more important concept. What is the sequence? What is the sequence? And according to the definition of a sequence, now we will discuss one more concept, that is the properties of Riemann integrals. What is the sequence? Here, this is also one of the important content in the first block. Already we will discuss through the offline classes. Some more problems are also practiced on sequences. Okay. Now, anyhow, today, and I also explained here what is the sequence. Okay, according to the definition of a sequence, now we must discuss about the one more the concept. What is a convergent sequence and subsequences? What is the monotonic sequence? Okay, sequence is defined here. SB any non-empty subset. Given the any non-empty subset, S from n approaches to the real numbers. Here, when the natural numbers approaches to the real numbers, that the subset is called a sequence. Now, sequence is denoted by set of Sn. Here, in the that is the notation of the sequence. That sequence is denoted by Sn. Here, n being a positive integer. When the natural numbers approaches to the real numbers, that the subset of a mapping is called a sequence. Okay. Now, according to the definition of a sequence, every set must define the one of the subset is there. And according to the sequence is also, we must define there are number of subsequences are there. Now, already we have discussed in the one more concept, the sequences, we will discuss in the next class is there. But here, main importance of the concept is a sequence. According to the definition of a sequence and the functions, we must explain the monotonic function or monotonic sequence. Now, if a sequence which is monotonic, either increasing or decreasing of the sequence is called, that is called monotonic sequence. Should listen carefully. Now, according to this definition, we must explain the properties of Riemann integrals. Without the definition, without the continuous function, we can't explain the properties of Riemann integrals. Now, here a sequence which is monotonic. When a sequence which is monotonic means given the sequence is increasing or decreasing. Okay. Now, what is the monotonically increasing? Increasing means that sequence is non-decreasing of this part. Okay. Now, here sequence is denoted by Sn. Here L being a positive integer. Okay. When the given the subset of the positive, when the domain of the numbers are positive integers, and when the domain of the elements are positive integers approaches to the real numbers, that is called a sequence. Okay, sequence is denoted by set of Sn. That sequence which is monotonic means either increasing or decreasing. What is the monotonically increasing? Increasing means that is the non-decreasing of this part. Okay. Now here S1 less than or equal to, because those sequences are explained in terms of, because here n being the first integer. First integer means all the first integers are natural numbers. Now, according to this one, put n equal to 1. To write the first sequence is S1. To put n equal to 2, the write the second sequence is denoted by S2. And so on. Here Sn is less than or equal to Sn plus 1. Now, those sequences that the pair of ordered. Now, those that the sequences represented as the ordered pair. Now, S1 less than or equal to, S2 less than or equal to, so on less than or equal to Sn and less than or equal to Sn plus 1. Okay, and less than or equal to so on. This is the ordered representation of a sequence. According to the ordered representation of a sequence, now that is the notion of Sn less than or equal to Sn plus 1. Suppose n equal to 1 is there. And according to the representation, n equal to 1 means this is the S2. Okay, that is S1 less than or equal to S2 and S2 less than or equal to S3 and again and so on. That is the in terms of n values, Sn less than or equal to Sn plus 1. Okay, here that is the main representation. A sequence Sn is said to be monotonically increasing or non-decreasing. Increasing means that is the non-decreasing. Now, here the condition is Sn less than or equal to Sn plus 1. Therefore, all n being a positive integer. Okay, put n plus 1 equal to m is there. Now, that is also the one of the representation. Sn less than or equal to Sm. For all n less than m. Okay, now that is the monotonically increasing. Okay, strictly increasing means now without the equal relation, that is Sn less than Sn plus 1. For all n being a positive integer, or Sn is less than Sm. Now, for all n less than m. So, either this representation or that representation, that is the strictly increasing. Strictly increasing means without the equality relation of the monotonically increasing, that is called strictly increasing. Okay, suppose n being a positive integer representation is n is always greater than 1. Okay, now by the mathematical induction, that is the representation of replacing n by n plus 1 is there. Now that is Sn is less than Sn plus 1. For all n being a positive integer, that is Sn less than, put n plus 1 equal to m is there, or Sn is less than Sm for all n less than m. This is the strictly increasing. Please note that this is one more point, very important point. Okay, next one, monotonically decreasing. What is the monotonically decreasing? A sequence Sn is said to be decreasing. This is the definition of decreasing of this part. Now this content is very useful in the first block and that is the third block. Now from the first block, when we understand according to this concept, then automatically to easily to achieve the third block of the concept. That is the properties of Riemann integral. Okay, now that is the monotonically decreasing. Okay, a sequence Sn is said to be decreasing. Given the sequence when it is the decreasing or at the same time non-increasing of this part. Okay, now that is the reverse of the reversal condition. S1 is greater than or equal to S2, greater than or equal to Sn, greater than or equal to Sn plus 1, and greater than or equal to so on. When the sequence is decreasing, means Sn is greater than or equal to Sn plus 1 for all n being a positive integer. Or Sn is greater than or equal to replacing n plus 1 by m is there. Okay. Now when Sn is greater than or equal to Sm for all n less than m, either this one or this one. That is the representation of given the sequence is monotonically decreasing or non-increasing of this part. Okay, Sn is greater than or equal to Sn plus 1 for every n being a positive integer. And at the same time, Sn is greater than or equal to Sm is there. Now, this is the definition of given the sequence is decreasing. Strictly decreasing means without the equal relation of decreasing of this part, that is the presentation of strictly decreasing definition. A sequence Sn is said to be strictly decreasing if Sn is greater than Sm for n less than for all n being a positive integer or n less than m, whatever it is. Okay, that is the strictly decreasing. Now, students, listen carefully. Now, all the definitions, all about the according to the definitions, when we are applying the conditions, especially, okay, those conditions that is mainly for the purpose of filling the blanks. Okay. Now, the definition of monotonic sequence. Now, this is also one of the important definition. A sequence Sn is said to be which is either increasing or decreasing. A sequence Sn is said to be a monotonic sequence, either increasing or decreasing. Now that is called a monotonic sequence. Now there are so many examples of increasing and decreasing. Just you have to see here. Or now just I asked only, I will ask in the filling in the blanks, given the sequence when it is increasing. What about the 1 by Sn? Hello? What about the 1 by Sn? Hello? Hello? 1 by Sn is called, that is the inverse of the sequence. 1 by Sn is called inverse of the sequence. That sequence is, when given the sequence is increasing and the reciprocal of the sequence is decreasing of this part. Students, listen carefully here, because when the sequence is increasing, then the reciprocal of the sequence is also decreasing. Okay, reciprocal sequence means that is the inverse of the sequence, that is the 1 by Sn. Suppose Sn is decreasing, and what about the 1 by Sn? That is also a increasing of this part. Okay. Now, one more example, just you have to see on the screen, please. Sn equal to n square. Okay. Here, n being a positive integer. When the positive, given the sequence of the base representation is n, here n being the positive integer, suppose that is the n square is there. That is the sequence. Is this sequence increasing sequence? Given the sequence is increasing sequence means replacing n by n plus 1. Replacing n by n plus 1. Sn plus 1 equal to n plus 1 whole square. Okay. Now about here n being a positive integer. Now n and what about the relation between n and n plus 1? Okay. that is n is always less than n plus 1, n plus 1 less than n plus 2, n plus 2 less than n plus 3, and so on, n plus r less than n plus r plus 1 for all n values. Now, applying on both sides the squaring on both sides given this representation, that is n square less than n plus 1 whole square. Already is given. What about the what is the n square? That is Sn sequence. And given the given sequence, through the given the sequence, n plus 1 whole square is Sn plus 1, because replacing n by n plus 1. That is Sn plus 1 equal to n plus 1 whole square. Suppose here finally the given relation is this is Sn, this is Sn plus 1. So finally Sn is less than Sn plus 1 for all n values. Now, according to this condition, this is the increasing sequence. Already definition, we have presented the definition of a sequence is increasing. That is Sn is less than or equal to Sn plus 1 for all n values. Now, automatically it is similar of the path. Sn is less than Sn plus 1 means this is the strictly increasing. Okay. Now, one more example is here. Just you have to see here. Sn equal to n plus 1 by n. Sn equal to n plus 1 by n. Given the sequence is a decreasing sequence. How to prove this is the given the sequence is a decreasing sequence? And Sn equal to n plus 1 by n can also be written as n by n is 1 plus 1 by n. Of the fractions, partial fractions, this is 1 plus 1 by n is there. To write the sequence, given the sequence, Sn equal to 1 plus 1 by n. And according to this one, replacing n by n plus 1 is there. Sn plus 1 equal to replacing n by n plus 1 means n plus 1 plus 1, that is n plus 2 by n plus 1 is there. Okay. Now, according to this one, of the partial fractions, this is 1 plus 1 by n plus 1. N plus 2 means n plus 1 plus 1 by n plus 1. N plus 1 by n plus 1 is 1 plus and 1 by n plus 1 is there. So this is the Sn plus 1. Okay. Now, is it okay? Here n is less than n plus 1 of the reciprocal sequence. 1 by n is greater than 1 by n plus 1. Okay. 1 by n is greater than 1 by n plus 1. Automatically adding on both sides, adding with 1 plus 1 by n is greater than 1 plus 1 by n plus 1. 1 plus 1 by n is Sn and 1 plus 1 by n plus 1 is Sn plus 1. Okay, this is the Sn is greater than Sn plus 1. Okay, now in the same manner, now this is the Sn is greater than Sn plus 1 means by the definition of a decreasing sequence, given the sequence is decreasing sequence. Okay, now in the same manner we will discuss the monotonic functions. Okay, what is the monotonic function? A function which is monotonic, either increasing or decreasing. Now, function representation, this is f of x1 less than or equal to, f of x2 less than or equal to, f of xn less than or equal to, f of xn plus 1. So, f of x1 less than or equal to f of x2 or f of xn less than or equal to f of xn plus 1. Okay. Now, that is f of xn is less than or equal to f of xn plus 1. So, when the f of xn less than or equal to f of xm or f of x1 less than or equal to f of x2 for all here same with the representation n less than m. Given the sequences, given the function is monotonically increasing. Or f of x1 less than f of x plus 1, that is also strictly increasing. The same manner monotonically decreasing means a function is that is the representation into the function. A function f of xn is said to be decreasing or non-increasing if f of x1 greater than or equal to f of x2 greater than or equal to f of xn greater than or equal to f of xn plus 1. And given the function f of xn is decreasing, f of xn is greater than or equal to f of xn plus 1. Should listen carefully. Now, already we have discussed the sequence of the concept, a sequence which is monotonic. But into the functions, especially f of xn is greater than or equal to f of xn plus 1. In the same manner, f of x1 is greater than or equal to f of x2 for all n being a positive integer. Okay, here f of xn is greater than or equal to replacing n plus 1 by m is there. That is f of xm. Okay, now without the equal relation, strictly decreasing here. A function f of xn which is either increasing or decreasing, that function of the part is called monotonic function. Okay, now student listen here, especially now this is the geometrical interpretation for continuity. Now before that, we must explain here what is the function of a limit. Okay, now without the giving the set, according to the set, there are number of subsets through the set is there. Okay, now every subset must be defined on the set, and in the same manner, who's the function of a limit? Because we give especially that is the representation of a sequence. Given that sequence is it convergent or divergent? Okay, now we will discuss in the next class a sequence which is convergent or divergent. Okay, and before that, especially that is the Riemann integrals concept here. Now, before that, we must explain what is the function of a limit. Okay. Now, function of a limit representation is limit f of x. Here, x approaches to L is there. Okay, x tends to L. When if the limit extends to L, f of x equal to L, then the representation of mod f of x minus L is less than del. For every del is greater than 0. Del be its neighborhood on horizontal axis. Okay. Now, what about the mod f of x minus L? Mod representation or absolute representation. It read as absolute value of f of x minus L is less than del, and this is the mod f of x minus L is less than del here. So f of absolute means the modulus means now either minimum or maximum here. Given the function lies between L minus del and L plus del. Now here L minus del is the left neighborhood and L plus del is the right neighborhood here. Okay. Now that function is lies between L minus del and L plus del. Now here del be any neighborhood, that neighborhood of the point representation, it is open interval of this part minus del and plus del. Okay. Now already here 5 to 2 is there. So this class is sharply we must begin at 1:30. Okay, please cooperate with us. Now this is the online classes for your only for your purpose, not my purpose. Okay. Now this is one of the more important concepts we will discuss about in this session. Okay. Now del be its neighborhood. The neighborhood lies between minus del and plus del is there. Okay. Please stay on the line. Please stay on the line. Please stay on the line. Okay. Now, now that is what is the neighborhood on horizontal axis? There will be any neighborhood that lies between minimum and maximum is there, lies between open interval minus del and plus del. Every neighborhood of each of its point is called open set. Student, listen carefully. According to all those concepts, this is the theoretical part. Without this theory, we can't explain the properties. Okay. Now, this is the one is interlinked with another one. And without sets, we can't define the sequence sets. Without sequence sets, we can't define the infinite series. Okay. Now, a function of the limit is also we must define here, and according to the limit function, that is then the properties are also explained here. Okay, and through a function which is continuous. Next, a function which is differentiable. Now, first of all, so we must know the definitions of enter all the concepts in real analysis. Analysis means that is the analyzation concept. What is the analyzation? Sets must be analyzed. Functions must be analyzed. Analyzation is also that is the variation of calculus variations for the differentiation and integration. Okay. Now, just listen carefully. Function of the limit is denoted by limit f of x equal to L. Then mod f of x minus L is less than del. For all del is greater than 0. That function lies between L minus del and L plus del. Here del be any neighborhood. Now that is the representation. L minus del is the left neighborhood and L plus del is the right neighborhood. So in the same manner, L minus del and L, that is the open interval of this part, that is the left neighborhood. L and L plus del, that is the right neighborhood, and according to the right neighborhood, we must define the right hand limit. Okay. Now del here del representation, that neighborhood is always greater than 0 and lies between minus del and plus del is there. Okay, this is the open interval. Open interval representation, it is lies between that is a small bracket minus del and del is there. Okay, what is the left hand limit? If limit f of x equal to L, here x tends to L minus, means x tends to L minus del. Del is always greater than 0. Del representation is greater than 0. So that is the condition for mod f of x minus L is less than del for all del is greater than 0. Because the function lies between, this is the definition of a left neighborhood is L minus del and L. Because this is the real line is there. So L lies between L minus del and L plus del. L minus del and L is the left part. L and L plus del is the right neighborhood of this part. Okay, so by the definition of left hand limit, that function lies between L minus del and L is there. What is the right hand limit? Now, if when x is greater than L, x tends to L plus means. Now, in the final examination, what about the x tends to L plus? X is greater than L. X tends to L minus means x is less than L. Okay. Now that is the meaning of this is L minus del and this is the L plus del. Now here del is always greater than 0. Now by the definition of right hand limit is mod f of x minus L, L less than del, function lies between L and L plus del. This is the right neighborhood of this part. When the both limits are equal, left hand limit equal to right hand limit. Now both limits are equal. Given the given function, the function of the limit must be exists is there. The limit of a function exists. Okay. Now, what is the given the function of the limit exists means limit x tends to L minus f of x equal to limit x tends to L plus f of x. That is left hand limit and right hand limit. So the given function of the limit must be exists. Okay. And another one, continuous function. What is the continuous function? Okay. Now, continuous function, that is the representation on vertical axis in the geometrical expression, that is if limit x tends to c, f of x equal to f of c. When the function of the limit x approaches to c, that is f of c, replacing x by c, that is f of c. Then, and before that, origin from the origin is defined mod x minus c less than del. Implies mod f of x minus f of c less than epsilon. For all epsilon greater than 0. Okay. Before that, now when the origin is defined from at x equal to c means absolute of x minus c less than del. That is mod f of x minus f of c less than epsilon. So this is the meaning of f of x lies between f of c minus epsilon and f of c plus epsilon. Okay. Now this is the neighborhood of f of c is there. Del neighborhood is minus del and del. Epsilon neighborhood is minus epsilon and epsilon. So epsilon neighborhood on vertical axis, then the neighborhood is representation on vertical axis, that is the y-axis. And del its neighborhood on horizontal axis, that is x-axis is there. Now those functional representation, f of del equals to epsilon is there. Function of del representation is the epsilon. So the f of x, like this is the meaning of mod f of x minus f of c less than epsilon. That is the definition of a continuity. And before that, a function of the limit x approaches to c that equals to f of c. Okay. Now that function lies between f of c minus epsilon and f of c plus epsilon. So f of c lies between f of c minus epsilon and f of c plus epsilon. Okay. Now, here the neighborhood of C is there. C is also consisting on horizontal representation C minus del and C plus del. Okay. What about the conversation between the epsilon and del neighborhoods? Because both neighborhoods are it is greater than 0. but that is the main relation of those neighborhoods. Epsilon is always greater than del is there. Okay, there are two types of continuity, left hand continuity and right hand continuity. Left hand means x less than c and right hand means x greater than c. If limit extends to c minus f of x equal to f of c, in the same manner, by the definition of continuity, and left hand continuity means x tends to c minus means x less than c. Mod f of x minus f of c less than epsilon, for all epsilon greater than 0. So the neighborhood of left hand continuity is f of c minus epsilon and f of c. And right neighborhood is f of c and f of c plus epsilon. Okay, student listen carefully. Okay, by the function of a limit neighborhood is del and continuity neighborhood is epsilon. Now then the relation in between function neighborhood, limit function of the neighborhood and function of the continuity neighborhood is epsilon is always yeah. So when the both continuities are same, right hand continuity means x greater than c. Okay, when the both continuities are same, then the left hand continuity equal to right hand continuity, given the function of the limit is, that is limit f of x equal to f of c exists is there. Okay, so especially just you have to see one more concept. This is the geometrical interpretation for continuity. This is very useful because the entire concept must be analyzed on the geometrical representation. Now, both neighborhoods, horizontal neighborhood and vertical neighborhood, that is del and epsilon, then the representation on x-axis and y-axis. Okay, and C neighborhood is on x-axis, C minus del and C plus del, and through the functional neighborhood is C neighborhood of the functional part f of c, and left neighborhood of the functional neighborhood is f of c minus epsilon, and C plus del of the functional neighborhood is f of c plus epsilon. Okay, now here del is greater than 0 and epsilon is greater than 0. In between the relation is epsilon is always greater than del. So del means a function of the del representation is epsilon. Okay, now in between upper limit and lower limit, or upper continuity and lower continuity, what is the difference between the upper continuity and lower continuity? So here the continuity part is f of c plus epsilon, that is upper continuity. Lower continuity is f of c minus epsilon. When the difference between those upper continuity and lower continuity, difference means upper value minus lower value. That is f of c plus epsilon minus of f of c minus epsilon. We are getting the value is 2 epsilon is there. Okay, this is 2 epsilon in between the upper and lower part. So that is called height of the continuity. At the same time, there are a number of similar names in the representation of height. So length of continuity or saltus, SALTUS, saltus. So that is the difference of the continuity. There are the number of similar names, height of the continuity, because that is 2 epsilon in between the upper value minus lower value. So that is 2 epsilon. Okay. So 2 epsilon, that is the representation is del, and epsilon equal to del by 2 is there. So what about the relation in between epsilon and del? Epsilon is always greater than del is there. Should listen carefully. There are so many important properties of continuous functions. I think about now enter the function of the limit and function of the continuity, function
Hello,
of the
sir.
hello. Tell me.
सर आपका आवाज नहीं.
Hello.
हेलो सर, आपका आवाज क्लियर नहीं आ रही सर.
It's not clear. Hello. Is this
हाँ,
okay?
आपका आवाज क्लियर नहीं आ रहा है सर.
That's actually this is not my problem, madam. Okay, but this is not my problem. This is the university delivery of the voice. Okay, main that is the main problem is through the net problem in university. Okay, so because voice is clear, because here there is no problem. Here it is no problem. Okay. Now properties of continuous function is just you have to see and check and verify through the YouTube is also there, because same class is also reproduced in the YouTube. Okay, Once again, you have to see and just you have to verify this class. Okay. Now, properties of continuous functions. The given function, it is continuous on closed interval AB, then it is bounded on closed interval AB is here. Okay. Every continuous function must be bounded. Every continuous function must be bounded. That is also one of the important properties of continuous functions. Okay. Just you have to see here. These are all properties of continuous functions. Well, first property is every continuous function must be bounded. So if f from f maps interval AB to R, if f is continuous, if the given function is continuous on closed interval AB, then automatically then it is bounded on closed interval AB here. Okay, that is the property. Here the property is continuous function is bounded. Hello? Continuous function is bounded. Is the converse true? Okay, but the given function, when it is bounded, but it is not continuous. So automatically the given statement in sometimes that statement of the converse is not true. Okay. Now so just see your textbooks. Need not be, not necessary. Okay, that is the presentation of converse. Okay. So especially I must explain here one more concept. Every function is continuous, then it is bounded. But not conversely means a bounded function is not continuous in sometimes. Okay. Second property of when the given function is continuous and bounded and attains its bounds. Attains its bounds means infimum and supremum on closed interval AB. That is the second property. Third property is the given function is it is dependent on closed interval AB. Now we must discuss the functional points f of A and f of B. It has the same signs. Same signs means f of A less than f of B, or f of A less than 0, f of B less than 0, f of A greater than 0, and f of B greater than 0. So then automatically f of x less than f of c is there. Okay. Now the given function is when the function is continuous and bounded on interval AB, it has the same signs. And our next property, intermediate value theorem. When the function is f defined, f is continuous on closed interval AB. When f of A equal to f of B, now f takes every value between f of A and f of B is there. Okay, it's not clear. So yeah, actually this is university transmission problem. Okay, please see and here. Now there is also your doubt is also rectified here. Okay. Now these are all properties. Opposite signs means f of A less than 0 and f of B greater than 0. Okay. And f of A greater than 0 and f of B less than 0. These are all properties of continuous functions. Already these properties of continuous functions I think in the first sem. Okay. First sem or second sem in the first year. Now a function of the continuity and a function of the limit that problems are also practiced in first year. Okay. Next one, properties of Riemann integrals. What are the properties of Riemann integrals? Now, by the definition, just have to see and refer this problem. And the next one, properties are also explained here. When if f of x equal to mod x plus mod x minus 1. If f of x equal to mod x plus mod x minus 1. Okay. F of x equal to mod x plus mod x minus 1 means this is the absolute functions. So x and x minus 1, these are all algebraic functional representation. That algebraic functions representation in absolute representation, because given the function is mod x plus mod x minus 1 is continuous on closed interval 1 at x equal to 0 and x equal to 1, but not differentiable. Student, listen carefully. this problem just for your understanding purpose, especially. Okay. So now what is the continuous function is bounded and how to derive? So you give the absolute function is continuous but not derivable. Derivable means that is the differentiation. Already we have explained the definition of continuity and a function of the limit. And at the same time, a function of the differentiation is also there. Function of the differentiation. Okay. Now see here, especially f of x equal to mod x plus mod x minus 1. Because my absolute representation means here and left part and right part. Left part is minus x, that is when the minus x means x less than 0, and plus x means positive value, here x is greater than 0. So absolute mod x equal to minus x and plus x. When x less than 0, mod x means x minus 0. Here plus x means x minus 0. Put a x defined at x equal to 0 means when it is x less than 0 and x greater than 0. X less than 0 representation of the value is minus x. X greater than 0 representation of the value is positive value. That is the plus x is there. And mod x minus 1, that is the representation of minus of x minus 1. Here x defined at x equal to 1 is there. So when the x less than 1, we are taking the value is minus of x minus 1. And x greater than 1 means we are taking the values plus of x minus 1. So both values are, we are taking the mod x plus mod x minus 1. The given function, hello? Now, hello? Okay, it's okay. Now, converting into the general function, so f of x equal to mod x equal to minus x. Mod x minus 1 equal to minus of x minus 1. So minus x and minus of x minus 1 is 1 minus 2x. Okay. And we are taking the next one, x greater than 0, means but it is less than 1. That is mod x equal to plus x, and this is minus of x minus 1. So x minus x and plus 1, we are getting the value is 1 is there. And both values are taking the positive, that is plus x and plus of x minus 1. That is 2x minus 1. So when the x greater than 1, we are getting the value is 2x minus 1. So at x equal to 0 is continuous. When the left hand continuity is limit extends to 0 minus f of x and limit extends to 0 minus del of f of x means 1 minus 2x. Okay, this is 1 minus 2 of replacing x by 0 minus del. Okay, now replacing of del is greater than del, replacing del by 0. So we are getting the values 1 is there. 0 minus x less than 0. X less than 0 of the function is 1 minus 2x. And replacing x by 0 minus del. Finally, that value replacing del by greater than del is always approaches to 0. So we are getting the values 1 is there. And right hand continuity. Right hand means x greater than 0 plus. Hello, Neeraj? Hello, Neeraj?
Sir.
Is it clear? Voice is clear?
Yes, sir. Yes, sir.
Okay, thank you. Some more students are also voice is not clear, sir. Okay, this is not my problem. Actually, this is university transmission problem. Okay. Next one. And one more is also added here. At x equal to 1 is continuous. Now already time is to 2:15 is there. So late joins and late comers are also joined here because this is your purpose only. Once again repeat here, through the online classes, once you have to check and verify in YouTube. Now that is BREAOU live 4. Okay. Through the YouTube is also just see and verify. One more number of times are also repeated same sessions. Okay. Next, at x equal to 1 is there. So both continuities are equal. When the left hand continuity and the right hand continuity both are equal, the given function is continuous at x equal to 0. Okay, at x equal to 1, Please stay on the line. Please stay on the line. Okay, at x equal to -1 means that is the left hand continuity and right hand continuity. So left hand continuity means limit x tends to 1 minus. So this is x less than 1. X tends to 1 minus means x less than 1. So the x when the what is the function about in the x less than 1? So just you have to see and verify that is the normal converting into the normal function. X less than 1 function is 1 is there. So that value is substituting here. So that value is 1. And x greater than 1 means that is the right hand continuity. That is limit x tends to 1 plus means 1 plus del, or x tends to 1 plus means x greater than 1. Then the greater than 1 function is 2x minus 1. Replacing x by 1 plus del. Here del is greater than 0. Del approaches to 0. So we are getting the value is 2 of 1 means 2 minus 1 is 1. When the left hand
No.
continuity, hello? Any doubts? When the left hand hello? When the left hand continuity and the right hand continuity, when the both are equal, so the given function must be exist. So in the examination, final examination, what about the existence? When the left part and right part must be equal, that is called the existence. So the given function f of x is continuous at x equal
Sir.
to
Sir,
hello?
please say only important questions, sir.
This is the one of the important because without this one you can't understand the properties of Riemann integrals. Okay, so that's why I explained much more concepts are also released in this session especially. Okay, so the given function is continuous at x equal to 1 is there. Should listen carefully. Important means because this is the mathematics. Okay, now number of problems are also there, number of theorems are also there, number of properties are also there. So every question must be concerned through the definitions. Okay, without definitions you can't understand here. Okay, that's enough. So this is the main concept, properties of Riemann integrals. Just you have to see and check once again. See this one, see in your textbook. This is the properties of continuous functions. Hello, students, listen this one. Just you have to see and refer. See in your textbook. Without textbook, please see on the screen. This is the one more important theorem, that is properties of Riemann integrals. This property is very important. Number of times you have to ask here. One of the last in the previous session is also there. Define Riemann sums. Please note down, students. Nearest. Hello, Neeraj and Titli, please note down, and number of students.
Okay, sir.
Please note down the question. Define Riemann sums. Define Riemann sums and Riemann integrals. In the examination point of view, a very important concept. Define Riemann sums and Riemann integrals. Prove that a necessary and sufficient condition for Riemann integrability. Necessary and sufficient condition for Riemann integrability. This is one of the important question by the definitions, through the definitions especially. Okay. Second one, find UPF and LPF. UPF means upper Riemann sum and lower Riemann sum. Already last class I have explained here. Given the function f of x equal to x, find UPF and LPF and W of PF. W of PF is called oscillatory sum. That is also denoted by O of PF. Okay. Third one, if f of x equal to 3x plus 1, if f of x equal to 3x plus 1 is integrable on is integrable on closed interval 1 comma 2 or closed interval 0 comma 1, whatever it is. Integrable means that is not simple integration. First of all, we must find the upper Riemann sum and the lower Riemann sum and upper Riemann integral and the lower Riemann integral through the values to find the given the function is integrable or not. Okay. See this one. Next one, state and prove fundamental theorem of integral calculus. State and prove fundamental theorem of integral calculus. That is also one of the important. Okay. See in your textbook. Okay. 7.2.14. These representations are also important in the fill in the blanks. What is the upper Riemann integral? Through the limit norm of the partition. Upper Riemann integral is upper limit a to b f of x dx equal to limit norm t tends to 0 u of pf. This is the only one more question. That is the fill in the blanks. Lower limit a to b f of x dx equal to, that is the lower Riemann integral. That is limit norm t tends to 0, lower Riemann sum. Okay. There are so many important, sir. State and prove Darboux theorem. State and prove Darboux theorem. Especially this is the third block. This is the 7.2.13. This is also one of the important in the final examination. 7.3.1. This is also one of the important, that is a necessary and sufficient condition of integrability. Okay. Now that is the simple question as on the short answers, UPF and LPF problems, lower Riemann sum and upper Riemann sum problems, and also simple properties. Prove that lower Riemann integral are less than or equal to upper Riemann integral. 7.2.12. That is the simple problems. Okay. Now, just you have to see and refer, that is the properties of Riemann integrals. That is, this theorem is very, very important. That is the gunshot theorems in the final examination are sufficient and necessary and sufficient condition of Riemann integrability. That is 7.3.1 and again 7.3.2 as on the short notes. This is the 4 marks question.
Sir, your voice is not clear.
Hello, this is okay? This is okay?
Once again, repeat the question.
7.3.2. In your textbook, 7.3.2, prove that if f is continuous on closed interval AB, if f is continuous on closed interval AB, then f belongs to, f is Riemann integral on interval AB. If f is continuous on closed interval AB, then f is Riemann on interval AB. F is Riemann integrable on closed interval AB. That is denoted by f belongs to R of AB. This theorem is very, very important in the final examination. Should listen carefully. This proof is okay. Now, this is the main property of Riemann integrals. Continuous function is Riemann integral. That is the simple proof. Just listen carefully and please see on the screen. Now, what is the definition of uniformly continuous? First of all, we must know the continuous function. What is the continuous function? Origin is defined from mod x minus c less than del implies mod f of x minus f of c less than epsilon. That is the definition of a continuity when limit x tends to c f of x equal to f of c. Okay. Now, here especially uniformly continuous means epsilon is greater than 0. There exists del is also neighborhood. That neighborhood is also greater than 0 such that for any two elements in between A and B is there. This is the interval point AB. Those interval is consisting of the element is X. X can be deviated into the two elements that is X1 and X2. We are taking the X and X1 or X1 and X2, whatever it is. Mod X minus X1 less than del implies mod F of X minus F of X1 less than X1. This is the uniformly continuous definition. So every uniformly continuous function is also continuous. So that's why simple continuous function is also uniformly continuous. Okay. Now recall that, and before that f is continuous on closed interval AB. That is the statement is given. That continuous function is Riemann on interval AB. So before we are taking, given the function is continuous, then automatically f is uniformly continuous. Because this is the main property of continuous and uniformly continuous. So by the definition of uniformly continuous, epsilon greater than 0 and del greater than 0, we are taking any two elements in between A and B. That is X1 and X2. These are two elements in between A and B is there. So from the definition, mod X1 minus X2 is less than del. So in X1, X2, those elements on horizontal axis, that is the x-axis. Okay, implies mod f of X1 minus f of X2 is less than epsilon by b minus a. So what is the b minus a? That is the interval difference. Length of the interval is b minus a. So in between here epsilon by 2 means in the Saltus, by the definition of Saltus, or height of the interval, so that functional neighborhood is less than epsilon by b minus a is there. Because epsilon is greater than 0. So interval of the element is, the interval of the difference is b minus a. So interval is a and b, that the difference is b minus a, but functional neighborhood is epsilon by b minus a. So here the main condition is mod X1 minus X2 is less than del, and mod f of x, so that the neighborhood of the functional element is f of X1 minus f of X2 less than del neighborhood. It is always greater, epsilon is greater than del is there. So according to that, functional neighborhood is epsilon by b minus a. Though this is the one of the part, the epsilon of the part is epsilon by b minus a, but it is less than epsilon. Consider this is any one of the partition. We are taking any one of the partition depends upon the interval AB. What is the partition set? A equal to, that is the initial point is x0 and x1, x2, so on, xr minus 1, xr and xn. Final point is represented denoted by b is there. What is the norm of the partition? Already we have to discuss the norm of the partition always less than del is there. Since the given function is continuous on R subinterval, so continuous function, we know that properties of continuous function are given the continuous function is bounded and attains its bounds. Already in this session, starting, we have to explain the properties of continuous functions. Continuous function is bounded and attains its bounds. Its bounds means there is the infimum and supremum. Infimum value is small mi and supremum value is capital Mi. The R subinterval is denoted by IR equal to closed interval XR minus 1 and XR. XR is the capital MR. XR is there is the supremum value. That supremum value depends upon the function f of XR equal to capital MR and f of XR minus 1 equal to small MR. So XR minus 1 and XR value represented as in terms of alpha values and beta values. That is alpha I and beta I in between xi minus 1 and xi. This is the R subinterval or I subinterval, whatever it is. We are taking the representation in terms of I. This is the I subinterval. So we are taking any two values, that is the boundary values, infimum and supremum, that is xi minus 1 and xi. It is the lower value and upper value. Those values depends upon the function. We are getting the f of xi minus 1 equal to small mi. That is f of alpha I equal to mi. F of xi equal to, that is the beta I. So f of beta I equal to supremum value. So in terms of alpha and beta values, mod alpha and beta I less than del, and those values representation in the functions mod f of alpha I minus f of beta I is less than epsilon by b minus a. That is the simple part. So that is the supremum minus infimum for ith subinterval values, it is less than, this is the capital Mi, this is the small mi. So capital Mi minus small mi. So when the supremum of the value and infimum of the values, it is completely based upon the functions, that is the values of f of alpha equal to small mi and f of capital beta equal to capital Mi. Okay. So enter the functional values less than epsilon by b minus a. So capital Mi minus small mi is less than epsilon by b minus a. Here I varies from 1, 2 and so on n values. So applying on this is the summation of the representation. So this is the representation del I. Mi del I minus small mi del I is less than epsilon by b minus a and del I. At the same time, summation of the values means I values reproduce here. Summation I equal to 1, it is varies from 1 to n values, capital Mi and del I minus summation I equal to 1 to n small mi and del I less than epsilon by b minus a into summation del I. So summation del I means length of the sum of the length of the subintervals must be equal to b minus a. So both b minus a values are cancelled. Already in the first session, we have explained here sum of the summation of del I will equal to b minus a. So interval of AB length is equivalent to summation of del I. All the length of the subintervals must be added here. That is the representation summation del I. That value is then equivalent to b minus a. Both values are cancelled here. Finally, this is the UPF minus this value is LPF by the definitions, and upper Riemann sum and lower Riemann sum is less than epsilon is there. So finally, that is the representation of what is the condition of this one? That the given function is Riemann on closed interval AB. F is Riemann on interval AB. So that is denoted by F belongs to R of AB. So this theorem is very important, students. The theorem, the given function is continuous on closed interval AB. Then F is Riemann on interval AB. This property is very important in the final examination, and don't mislead here. This theorem is very important in the final examination. Student, next class we will explain the one more important theorem. Given function F varies from interval AB to R is monotonic. Monotonic is also just for the from the definition of monotonic, either increasing or decreasing, and according to the definition, that property must be explained here. Monotonic function is also a Riemann on interval AB. So F is Riemann integral on AB means when the function is monotonic. First of all, so before that increasing means non-decreasing of this part. Okay. Now there is no problem. Next class we will explain here. One of the important theorem is that function is monotonic on interval AB, and some other problems are also practiced, and there is no doubt this theorem is also very important. Students, please note down 7.3.2, 7.3.3. These two theorems clubbed in the essay question. Okay, and now at least one question is given, that is the short answer. Okay, there is no doubt. This theorem is also very important. These 2-3 theorems, and along the last sessions are also explained here. That is necessary sufficient condition of Riemann integrability and a fundamental theorem of integral calculus. And next class, the one more property are also explained here. That is the monotonic function is Riemann integrable, and some other problems are also practiced and mean value theorems. Okay. Now, please note down this problem is also very important. 7.3.5 from the definition of Riemann integration. From the theorem of Riemann integrability, this theorem is also very important. Already last class explained here. This theorem is very important. This problem is very important. That is, given the function is x square, it is defined on closed interval 0, a. So F is Riemann on interval 0 and a. So simple integration is integral A square means a cube by 3. Integral x square means x cube by 3. Replacing the interval points 0 to a. Upper limit a is there, lower limit 0. So upper limit value is a. So that is the x cube. Replacing x by a is a cube by 3. But it is not simple integration. From the theorem of Riemann integrability, now we must derive the problem integral 0 to a f of x dx. But here the function is x cube is there, x square is there. So that value is a cube by 3. This problem is also very important, 7.3.5. Please note down. So please give any suitable example. F is Riemann on interval 0, 1. So one is the rational and irrational. That function is the F is not Riemann integrable on closed interval 0, 1. Okay, define Riemann integrable. Define Riemann integrals. Give any example F is which is not Riemann integrable on closed interval 0, 1. F is not Riemann integrable means one is the rational value is 1 and irrational value f of x equal to -1. This is the suitable example of F is not the Riemann on interval 0, 1. This problem is also very important. Okay, students, these problems are also practiced here. If you have any doubt, next class are also explained here. And one more block, that is the sequences. And the sequences important, the theorems and also problems practice in the next session. Okay. Anyhow, wish you all the best and wish you good luck. And please see and check in your WhatsApp group. Enter all the material must be posted through WhatsApp is there. Just today are also today's class are also posted the material. Please see and verify that notes. Okay. Thank you one and all students. And now, once you have to repeat this class, please check and check and watch the in YouTube is there. Okay, that is the BRAOU live 4. Please check and watch this class one more. So you have to repeat this one. BRAOU live 4. Okay, that is the site here, and number of times are also repeated and watch this class. Previous class are also there, and just you have to rectify the problems. Okay, thank you one and all, and wish you all the best. Hello, 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 Neeraj.
Thank you, sir.
Okay, wish you all the best, and the remaining 2 classes are also
Okay,
very
sir. Okay,
important.
okay.
Don't miss that. Okay.